All right, so now onto the grid ends. We're starting off here with number 31. So 31, it says that Wyatt, he can husk at least 12 dozen ears of corn per hour. So they're giving you a rate, and then at most he can do 18 dozen ears of corn per hour. So based on that information, those two rates that were given, what is the possible amount of time in hours that it could take Wyatt to husk 72 ears of corn. So again, these are rates, and what they're doing is a very straightforward rate. We can do 12 at minimum, 12 dozen ears of corn per hour. So if I want to do 72, what I would do is I'd go 72 equals 12 times my time, or my number of hours, and I would solve that and see what I get. So this time would give you 6. So we know that it is greater than or equal to 6. Or actually that'd be less than, because the time would be bigger at that point. So I'll just fix that. That's less than or equal to. And then if he goes a little bit faster, you can go 18 dozen ears of corn per hour. So here I'm going to go 72 equals, and I think we said 18 times t. And you multiply those, or divide, sorry, both sides by 18, and you're going to get 4 for your time. So again, we want an answer that's somewhere in between these numbers. So t has to be less than or equal to 6, or greater than or equal to 4. You just pick a number. Like if I was doing this, I'd just say 5. That'd be a good enough answer. But anything in this range would be perfectly acceptable for an answer on number 31. So that's going to again be 31. Now number 32, they're asking you, they're giving you a posted weight limit for a covered wooden bridge in Pennsylvania, 6,000 pounds. So they're telling you how much you can hold. And then they're telling you we have this truck. Now this truck is carrying X identical boxes each. Now that word each, just so you know, that is a rate. When you see the word each, that means you're probably going to be multiplying by something, because that's what you do with your rates. So we have X boxes each weighing 14 pounds. So I'm thinking 14X will probably show up in my equation. You'll see it in a minute. And then we say we have, if the combined weight of the empty delivery truck and its driver is 4,500 pounds, they want the maximum value for X, so how many boxes can we hold, so that we stay under that 6,000 pound limit. So what we're getting is something like a linear equation here. Okay, we're going to get a slope-intercept form. We want to make sure that whatever we get is less than or equal to 6,000, because we want to be under that weight limit. So to get there, we have, again, that 4,500 pounds, and then we have that 14x. So I'm going to think 14x, 14 pounds for each box, plus the 4,500 pounds that we initially had for our empty car. We want this to stay less than or equal to 6,000 pounds. So I'm going to solve this for x to see how many boxes I can have. So I'm going to subtract 4,500 from both sides. So that here is going to cancel. We get 14x, and that is less than or equal to 1,500. And then we're going to divide by 14 on both sides. Now when you do that, you're not going to get an answer that's perfect, and that's okay. But we're going to get 1,500 divided by 14 is 107.14. So, you know, obviously, if we added another box, an 108th box, it would be over the limit. So they say, what's the maximum number of boxes can we have that would keep us under it? Well, that's going to be 107 boxes. So our answer is going to be 107 for number 32. So that's 32, and then you move on to 33. We got a couple of quick ones here. 33 is just asking you to literally do what it says, make a fraction. So they're telling you, according to the line graph above, the number of portable media players sold in 2008 is what fraction of those sold in 2011. So you figure out how much they sold in each one of those years and divide them. So in 2008, you look and you see 100. So I'm going to put 100 here. And in 2011, it looks like it's 160. So we're just going to start reducing this. I'll start by canceling out a factor of 10. And again, you have a calculator too, and your calculators can, if you have the right type, will literally simplify this for you. But here I'm doing it by hand. Now I'm going to divide both the top and bottom by 2. So that's going to be 5 over 8, and that is about as simplified as it's going to get. So number 33 is 5/8. You just do what they say. They say set up a fraction, well I set up a fraction and I simplified it. So that's number 33. Number 34 says we have a local television station sells time slots for programs in 30-minute intervals. So if the station operates 24/7, what is the total number of 30-minute time slots they can sell for Tuesday and Wednesday? So this is another very quick question. Again, we have 30-minute time slots. So in a full day, for the number of time slots, we're going to go 24 times 2. And that's going to give us, and again, 24 hours in a day. So for 48, we have 48 time slots in one day. And then we have 2 days that we're selling for. So that's 2 days. And again, this is the 30-minute slots per day. And this right here is the number of days, Tuesday and Wednesday. Multiply those together. And here we're going to get 96 total slots over the 2 days that we can sell. That's all you're doing on 34. So 33 and 34 should be fairly quick questions if you approach it in the proper way. So then we move on to number 35. Now 35, they're giving us a cylinder. Now one thing I always talk about when I teach geometry, I always tell you, write the formula out that they're asking you to work with. In this case, it's the volume, because we have a cylinder and they tell you the volume is 72 pi cubic yards. So the first thing I would do is write that formula, and volume is equal to pi r squared h. And notice they gave me the volume and the height. They told me the volume is 72 pi. So I'm going to write 72 pi. And if you look at the picture, you'll see the height is 8. So this will be pi r squared times 8. And that's just what you're given. Everything tends to be in yards, so I don't have to do any conversions, which is great. I just need to find the diameter, not the radius. I will solve for the radius. You just have to know to double that number to get your diameter. So you're going to divide both sides by 8. So that's going to give you 9 pi equals pi r squared. Well, that means r squared is equal to 9. So r is the square root of 9, which is 3. However, we're not looking for the radius, we're looking for the diameter. So to get the diameter, you're just going to go 2 times 3, so your diameter is going to be 6, and that's going to be number 35. Make sure you don't get caught up in solving for the radius and you forget to convert that to diameter. They're going to probably try to get you on that. So make sure you're paying attention. All right, so that's 35. 36 is giving us an equation, a fractional equation, and they're asking you for which value of x is this function undefined. So you have to understand what's undefined when you have a fraction. So that's what I have here. So if a fraction is going to be undefined when the denominator is equal to 0. So that's what we have to know for number 36. And we're going to have a denominator down here with an x in it, so it can equal 0. So we're going to write the denominator out, which is x minus 5 quantity squared plus 4 times x minus 5 plus 4 equals 0. Now I could tell you at this point to multiply everything out because this is a quadratic, so you have to multiply everything out, combine like terms, and then factor. But I want to show you that there is a faster way to do this. So I want you to think of this right here as if it was in the form a squared plus 4a plus 4. And if we were factoring this, you would break it up into two binomials. This would be a, 2 and 2 add up to 4. And this would be your factor if that was in terms of a. Well, watch what I'm going to do with this. I'm going to break this up into two binomials. I'm going to use brackets on this one. You'll see why. The brackets, again, are nothing more than parentheses. And I'm going to think of this a as, in this case, x minus 5. So how do you get x minus 5 squared? Because that's going to be your first terms here. Well, you go x minus 5, x minus 5. And then for your constants, 4 times 4, or 2 times 2 equals 4. And 2 plus 2 adds up to 4. Your product and your sum both work if these are both positive. So notice this is this. They just have it with x minus 5s instead of a's or whatever that variable would normally be. So that means my factors, when you solve this, you set your factors equal to 0. Well, these factors are the same. So I'm just going to pick a factor. I guess I'll pick this one. It doesn't really matter. They're the same anyway. And I'm going to set it equal to 0. So I'm going to go x minus 5 plus 2 equals 0. I don't need the parentheses anymore because it's not like I combine them with anything. So I have no parentheses. I get x, and then this is minus 3 equals 0. So x is equal to 3. And they're looking for x, and that's the only answer you get. So x is 3 for number 36. So again, this can be solved by multiplying everything out and then factoring. You're going to get the same answer, just going to take you a lot longer to get there. So this is a great little shortcut if you can see it. So that's going to be number 36. Next up, we have number 37. And this one is describing, there's a little paragraph, there's two problems attached here. So in 37, it says Jessica opened a bank account that earns 2% interest compounded annually. Her initial deposit was $100. She uses that exponential equation that they're giving you. Now, before when I see this, the first thing that's going to jump to my mind is the standard form of an exponential equation. And if you know this, you're going to be doing great in these problems. And this is your standard form where A is your initial value and B is your rate, or the number you're multiplying by, or the percentage you're raising or going down. It depends on the problem each year. So in this case, they're telling me we had an initial deposit of $100, and you'll see in that equation 100 is your initial, and then x, well, that's your rate. Well, they're telling you that she earns 2% interest. So my equation is going to look like this. It's going to be y equals 100 times my rate of 2%. So again, you're earning 2%, which means we add 2% to 1. So this is going to be 1.02 for your rate, so you're going up 2%. And that's going to be, in this case, they have it to the t. So I'm going to raise that to the t power. So that's your equation. And that also answers number 37, because it says, what is the value of x? Well, that's your rate. This is my x, the way they have it labeled. So 37 is 1.02. You just write it down, you got your answer. So that's 37. And then 38, they're telling you that we got Jessica's friend, Tyshawn. Well, he has an account that earns 2.5% interest. And again, he also deposited $100, but he has a higher interest rate. So if you kind of skim through this paragraph, what they're asking you is, after 10 years, how much more money has Tyshawn earned? So I want to basically take this equation and Tyshawn's equation, map them out for 10 years, and see how much more they've earned. So I'm going to start here actually with Jessica. That's the one I already have. So I'm going to write that first. So we have Jessica, which we have this equation, but I'm going to plug it in to the 10th power. So this would be 100 times 1.02 to the 10th power. And I'm going to see again what that gives me. So if I go 1.02 to the 10th power times 100, she has currently a total of $121.90. So that's Jessica after 10 years. So she's earned $21.90. And then Tyshawn is next. And again, he has also deposited $100, so that number's the same, but my rate is now going to be 2.5%. So I'm going to go 1.025, raise that to the 10th, because again, that rate's going to be, it's going to be 2.5%. It's higher, so I'm going to earn more money. So I'm going to go ahead and multiply, take 1.025 to the 10th, and then I'm going to multiply that number by 100, and I'm going to get $128. And it looks like we have 1 cent if you round to the nearest hundredth. So those are my two amounts, and they want to say how much more has Tyshawn earned. So now what I'm going to do is I'm going to go 128.01 minus 121.90, and I'm going to see what the difference is. So you take those two numbers, so 128.01 minus 121.9, and we're going to get 6.11. So that's how much more. I mean, it is a dollar amount, but this is what you're plugging into your grid in box, 6.11 for number 38. So again, that's number 38, and that is test 1, section 4.